Flutter allows performance faster than many other cross-platform frameworks by using a unique rendering architecture. Today, we're diving into the heart of this architecture, the three trees that power its rendering system. These are the Widget Tree, the Element Tree, and the Render Tree. Understanding these trees will help you build better, more efficient Flutter apps. First up is the Widget Tree. Think of it as the blueprint for your app. Every widget in Flutter, whether it's a text widget, a button widget, or a column widget, is a blueprint describing how your app should look and behave. This tree is entirely declarative, meaning you describe what you want and Flutter takes care of creating the structure. Widgets in the tree are lightweight and immutable. That immutability means whenever the app's UI needs to change, a new widget tree is created. However, the widget tree is only a high-level representation. Flutter uses this tree to define the intent of the UI, but it doesn't directly represent what gets rendered on the screen or how updates happen. To achieve that, Flutter needs something dynamic and state-aware, and that's where the element tree comes in. The element tree is a dynamic structure that bridges the gap between the static widget tree and the low-level render tree. Unlike widgets, which are immutable, elements are persistent. Each element represents a specific instance of a widget in the UI. When a widget is instantiated, Flutter creates a corresponding element. If the widget is a stateless widget, it's linked to a stateless element. Similarly, stateful widgets are linked to a stateful element. One of the most critical roles of the element tree is handling widget updates through reconciliation. When the widget tree changes, Flutter compares the old widget tree with the new one, updating only the affected elements in the element tree. This process ensures efficiency as only the necessary parts of the UI are rebuilt. Elements also serve as a link to the underlying render tree, passing down configuration information from widgets to render objects. Now, let's take a closer look at the render tree where the actual rendering happens. The render tree is made up of render objects, which handle layout, painting, and hit testing. Render objects are responsible for taking constraints from the parent nodes, calculating their own size and position based on these constraints, and passing information to the children. This hierarchical layout system ensures flexibility and precision in how widgets are displayed on the screen. There are different types of render objects, each specialized for various tasks. For instance, RenderBox handles box-based layout, while RenderFlex manages flex layouts like rows and columns. The beauty of the system is that each render object is highly optimized for its specific role. In addition to the layout, render objects are responsible for painting the visual content. Each node in the render tree generates painting commands, which are instructions for drawing pixels on the screen. These commands are then sent to Flutter's Skia engine, which takes care of the actual rendering. The render tree also handles hit testing, determining which part of the UI was interacted with by the user. This is particularly important for handling gestures and touch events. So to sum up, the render tree is where the low-level pixel-perfect magic happens, translating high-level widget descriptions into beautifully rendered UIs. Let's bring it all together. The widget tree is the immutable blueprint that defines your app's structure and intent. The element tree is a dynamic, state-aware layer that tracks widget instances and links them to the rendering counterparts. And finally, the render tree is the powerhouse responsible for layout, painting, and hit testing. This architecture allows Flutter to achieve its hallmark performance and flexibility. By separating concerns across these three trees, Flutter can efficiently rebuild UIs, handle state changes, and render smooth, responsive interfaces. And there you have it. The three trees of Flutter rendering explained in detail. Understanding these trees is key to making your apps even better. Thanks for watching and see you next time.